In this section, we're going to be looking at nomenclature, naming compounds. We will be learning how to name compounds based on the names of the polyatomic ions and multivalent elements and regular elements that are involved in chemical reactions that form compounds. Here's a reference sheet that you will need throughout this section. This reference sheet will be present when you're writing a test or a quiz, so you don't have to memorize any of these names for polyatomic ions, multivalent elements, or the molecular prefixes. These will always be provided to you, but you'll need to come back to this sheet often as we learn the different rules for naming the different types of elements and compounds. Let's start with naming ionic compounds. Binary ionic compounds are composed of two elements, a metal and a non-metal. Here's the rule. Name the first metal followed by the non-metal with an ending IDE. For example, NaCl. To name this, we will look at the name of the first metal, sodium, and the name of the second element, chlorine, but we're going to change the ending to IDE, so it'll be sodium chloride. Polyatomic ions are ions that are composed of more than one atom. So we're going to use the name of the polyatomic ion as it is. So we'll name the first metal, in this case sodium, and then we're going to name the second polyatomic ion and we'll give it the name as it is. Let's find what the name for NO3 is. Looking at our reference table, we have NO3, which is nitrate. So the name of this is the name of the first metal plus the name of the polyatomic ion as it is. So it's sodium nitrate. Let's try some practice questions. Here's a binary ionic compound. Name of the first, potassium. Name of the second is bromine, but we'll add the ending IDE. It's potassium bromide. Next, we have calcium and the polyatomic ion CO3. Let's look on our table. Let's find CO3. Its name is carbonate. So we'll write the polyatomic ion as it is, carbonate. In this next example, we have iron. But iron is a multivalent metal. And we're going to look on the multivalent metal to see which one we are looking for. Iron is either Fe2+ or Fe3+. So how do I know which one is used in this example? Iron 2 or iron 3? Well, let's take a look at this compound. Oxygen, because it's in group 16 or group 6, has a valence of 2. And when you bring this valence down in the crisscross method to form, that means that the chemical formula would be Fe2. So where did this 3 come from? This 3 that is present was the valence of the iron. So in this example, This is iron 3 because it has the valence of 3. So this 3 ends up at the bottom here. We have O3. So we'll add the name of the metal, the Roman numeral that we've decided from our multivalent metal table above, plus the name of the second element with the ending IDE. So it's going to be iron 3, and instead of oxygen, we write oxide. So those are the rules for naming ionic compounds, both binary ionic compounds and those that contain polyatomic ions. Now let's look at naming molecular compounds. Binary molecular compounds are compounds composed of 2 nonmetals. The rule for naming molecular compounds tells us that we have to use prefixes to indicate the number of each atom. For example, in our table of prefixes, 1 is indicated by mono, 2 is di, 3 is tri, tetra, penta, hexa, hepta, octa, nona, and deca. Look back at this table if you need to remember what these prefixes are. So, first example, CO2. CO2 has 1 carbon and 2 oxygen. So, the prefix for 1 is mono. So there's monocarbon and 2 oxygen, that's dioxide. Again, we have the ending IDE. Now, I want you to know this important rule. We don't use the prefix mono except in a special case, which I'll talk about later. So this molecule, we ignore the mono and we call it carbon dioxide. Let's try this sample problem. 2 nitrogen is dinitrogen, and 4 oxygen is tetraoxide. Again with the ending IDE. Sulfur has only 1, but as we mentioned over here, we don't indicate 1 unless it's a special example, which I'll talk about later. So it's sulfur, and there's 6 fluorine. So in this example, if we look at our prefixes for 6 is hexa. So this becomes hexafluoride. Again with the ending IDE. There's 1 phosphorus in the next example. We don't put mono unless it's a special example, which I'll talk about. So we have phosphorus and 3 chlorine, that's trichloride. Tri meaning 3. So what's the special example? When do we ever use mono? Mono is used only in the case where there are 2 atoms in a molecule and each of the atoms have only 1 atom in the chemical formula. So The way we write this would be monocarbon, monoxide, or monoxide. We don't write a double O. But when this happens, we ignore the first mono, so we just write carbon monoxide. So we add mono only when mono should be used in both elements, but we ignore it for the first and only use it in the second. Another example is naming acids. Binary acids are composed of hydrogen and one other element. We use the prefix hydro and the suffix ic, followed by the word acid. For example, HCl is a binary acid, and we call this hydrochloric. So we change the ending to ic and add the word acid. Oxyacids are acids that contain hydrogen, oxygen, and another element. If the anion in the table, the reference table up above, ends in ATE, then the acid will end in ic. If the anion ends in ITE, then the acid ends in us. So, here we have hydrogen and an oxy polyatomic ion. The polyatomic ion is SO4. Let's go back to our reference table and find SO4. SO4 has the name sulfate. Sulfate has the ending ATE. So, when it ends in ATE, we are going to use ic. ATE, ic. So just like we did for a binary acid, we're going to write hydro for hydrogen. And then for the sulfate ion, we're going to write sulfuric. And this is because it ended in ATE, sulfate. And then the word acid. Hydrosulfuric acid. In these examples, you don't have to include the hydrogen, so this is simply sulfuric acid. We know that there's a hydrogen present in an oxyacid, so we're just using the anion to name the acid. So H2SO4 is sulfuric acid. Let's take a look at this oxyacid, HNO3. Let's find NO3 on our reference table. NO3 is nitrate, so it's going to use the ending IC. So this will be nitric acid. How about SO3? Let's find SO3 on our reference table. SO3 ends in ITE. So if it ends in ITE, then we're going to give it, instead of the ic ending, we're going to give it the us ending. ITE, name the acid with us. So this is sulfurous acid. The third example is a binary acid. So this is hydrobromic acid. Let's take a look at how to name bases. Bases typically contain the ending for the ion OH, which is the hydroxide ion. And the rule for naming bases is name the metal followed by the word hydroxide. So here we have sodium hydroxide. In these examples, these are relatively simple. We have potassium hydroxide, calcium hydroxide, and aluminum hydroxide. Let's do some mixed practice. First example, we have a metal and a nonmetal. This is a binary ionic. So this is magnesium chloride. Here we have two nonmetals, so we're going to use the prefix method. Note, both carbon and oxygen have only one element. So we're going to use the prefix mono, but not on the first carbon, only on the second single atom, which would be monooxide or monoxide, because we don't write a double O. Next, we have H2CO3. CO3 is the carbonate. From our table, we can see that it's carbonate, our reference table above. 8 is ending, we name it with ic. So this will be carbonic acid. And the fourth example, since it's a hydroxide, name with the first, this is ammonium. NH4 we can find on our reference sheet. It's polyatomic and is ammonium hydroxide, since it's an OH base. Try any practice problems, worksheets, and LMS quizzes. Good luck.